Good morning everyone, this is Shivani Agarwal. I am the Assistant Professor of Department of Information Technology in AKGEC Engineering College, Ghaziabad. So today my topic is main memory and the RAM chip and the ROM chip and the memory address map table. So we start with the basic of the main memory. So basically main memory is the central storage unit in the computer system that is basically relatively large and the fastest compared to the cache, but it is basically small as compared to the secondary storage. So we use to store programs and data during the runtime operations. So this is the basic of the main memory. Now we have two types of memories are there, that is the RAM and the ROM. RAM is basically random access memory and ROM is the read-only memory. So basically we have to emphasize about the chip construction of the RAM and the ROM. So basically this is the RAM chip designing. There are some important discussion about the RAM chip, that the size of the RAM. So this is the size of RAM. This is 128 into 8. What it means? 128 means there are, if this is the RAM, so there are the words, that is 128 words are there, started with 0 to 127. So there are the words. How many words are there? This is totally depends on the size. So size is 128 into 8. So this 128 means we have the RAM organization from start with 0 to 127, and we have the size is 8-bit. This is the individual word size. So if it is 8, that is 120 into 8. So it is the size as 120 into 8 means 8 is the number of bits we use in the particular word. So one word equals to 8 bits or 1 byte. So this is the basic representation of the size of RAM. If this size is changed, that is basically 512 multiplied by 16. So what it means? So basically it start with 0. First word address is 0 and it is till 511. So this is basically the size of RAM. And what it means 16. So at this time the word size is basically 16 bits. So this is the basic of the RAM chip designing. What is the size of RAM and how we have to define that particular size. So this is the basic. Now how many address lines are there if the size is 128 into 8? So basically 128, the representation of 128 with the 2 to the power n. So basically 2 to the power n equals to 128. So what is the value of n is there? So n is basically 7. So this is the address line. So this is basically AD7. So there are the 7-bit address required for defining the size of 128 into 8. And there are also defined the read and the write commands. So basically the basic working of RAM, that we have to read the data or the write the data. Both operations are we have to perform in the RAM chip. So we use RAM read and write. Both signals are used in the RAM chip. Now CS1 and CS2 complement. What it means? CS1 is used for the chip select one. Which RAM chip you have to select? So this is this chip select we use for selection the RAM chip, and CS2 complement means we have to select either RAM chip or the ROM chip. So this particular chip selector we use for the RAM or the ROM chip selection. So this is the basic of the RAM chip. Now this is the basic description that we have to already explain, that there are the 128 memory locations, 8-bit size data as a word size, that is a one word represent as 8 bits or the 1 byte. Read and write chip control lines we have to use for designing the RAM chip. Now the CS1, this is chip select 1 and chip select 2. So chip select 1 we use for the RAM chip selection, which RAM chip you want to select, and CS2 is used for the RAM and the ROM chip selection. So this is basically basic the RAM chip. Now this is the basic table, that how we define this particular data with the table format. So this is when the chip select 1 and chip select 2 is 0 0. So read and write, there is no operation is performed. So it is inhibited, known as the high impedance, that is Z. This is already explained the high impedance in the common bus system. and that CS1, CS2, if CS2 is 1, so there is no response with the RAM chip, because CS2 complement we use as the ROM chip selection. So this is basically high impedance in this particular case also. But when the chip select is 1, but read and write is 0, so it is also high impedance, because no operation is performed in this particular case. But when the chip select is 1 and the read and write, either read high or the write high, so one operation perform at a time. So when the write high, so it is the write operation is performed. When the read high, so it is the read operation is performed. So this table is described that particular operations. Now the ROM chip. So this is same as the RAM chip. The size description, the word size, both are same, but we have to just define the chip select as the ROM chip, like the CS2 complement is used for the ROM chip selection, and at that time the CS1 chip selector is absent because this is not used in the ROM chips. So this is the basic as same as the RAM, and the address size is 9. How we use the address size is 9? Because the size of ROM is 512 by 8. So it is basically what? 2 to your n equals to 512. So basically, what is the bit size of n? N is 9 in this particular case. So the address bits are 9 we used for selection the particular word size with respect to that particular address lines. So this is the ROM chip organization. Now these are the basics that we already explained. Now this is the important thing, that is address map table or memory address map. So how we have to represent that memory address map table with respect to the hexadecimal addresses, how we have to implement or how we have to design this particular memory address map table with respect to the RAM and ROM organization. So basically the question is that a computer system needs 512 bytes of RAM and 512 bytes of ROM. So computer system needs, the requirement of the computer system is 512 bytes of RAM and 512 bytes of ROM. But the RAM chip size and the ROM chip sizes are, RAM chips is 128 bytes and the ROM chips is 512 bytes. So how many address lines as defined with the size of the RAM? So it is 128 bytes. So the size, the address bits we require, that is the 7 address bits, because it is 2 to the n 128. So n is 7 in this case. When the size of ROM is 512, so basically the address lines are 9. Same in this particular concept that is already explained in the previous slide. So this is the basic address line defined or totally based with the size of the RAM and the ROM. Now, how many chips we required at the design of the computer system? So the requirement of the computer system or the need of the computer system is 512 bytes of ROM, but the size of the RAM chip is 128 bytes. So how many RAM chips are needed? So this is basically we have to define that this is the complete size, that is 2 to the power 9, and individual RAM size is 2 to the power 7. So it is basically 2 to the power 2. This is 2 basically, right? So this is 2 to the power 2 equals to 4. So 4 RAM chips are required in this particular question. So how many RAM chips are required? There are 4 RAM chips are needed for construction of the computer system. And how many ROM chips are required in this case? Because the required size of the ROM is 512 and the size of the ROM individually, that is also 512. So it is basically 1 ROM chip are required in this particular case, right? I think it is very clear now. Now this is the same answer that we have to explain. Now move on this particular slide. This is very important, and you know about the hexadecimal address construction, how we have to define this particular table with respect with the size of the RAM and the ROM, and how many RAM chips are needed and how many ROM chips are needed. So we have to construct and how many lines, address lines we required for this particular question. So basically hexadecimal means we start with the 0 to 15 or we say that 1 to 16 because the base of the hexadecimal is 16, right? So this is basic. Now we start with the address line 1. If we start with the address line 1 and we have to move with the address line 16 because we start with 1. If we start with 0, then we have to move with the 15 in this case. But how many address lines we used in this particular question? Because the size of RAM and the size of ROM we know. How many RAM chips are required? That also we know. How many ROM chips are required? That also we know. So, we required 4 RAM chips in this particular question and we require 1 ROM chip in this particular question. The computer system needs 512 bytes of RAM and 512 bytes of ROM, but the RAM size is 128 into 8 bytes and the ROM is 512 into 8. So, we required 4 RAM chips and the 1 ROM chip. Now, we have to design the hexadecimal addresses and which address we have to use for which either RAM or ROM. So, we have to decide this in this particular table. So, because the size of RAM is 128 into 8 and we required the address lines, that is AD7. So, basically the 7 bits are used for the RAM, either RAM 1, RAM 2, RAM 3, RAM 4 because we required the 4 RAM. So, we define the name of the RAMs are RAM 1, RAM 2, RAM 3, RAM 4 and 7 address lines are used for the RAM. So, this cross shows that there are the predefined addresses of RAM, that is 7, starting from 1 to 7. So, there are 7 address bits are used for each RAM, either RAM 1, RAM 2, RAM 3 and RAM 4. But in the construction of ROM, how many address lines are used? Because the size of RAM is 512, so obviously we required the 9 address bits. So, this is the 9 address bits are used for the ROM construction. Now, how we have to select which RAM we have to use? So, how we have to select that the RAMs because we have the 4 RAMs, RAM 1, RAM 2, RAM 3, RAM 4. So, actually we use the decoder, that is a 2:4 bit decoder. So, each 2 bit we have to select with the RAM. So, this is the 0, 0, 0, 1, 1, 0 and 1, 1. So, when the input is 0, 0, so RAM 1 is selected when the input is 0, 1. So, RAM 2 is selected when the input is 1, 0. So, RAM 3 is selected and when the input is 1, 1. So, RAM 4 is selected. So, basic construction of the RAM and ROM is we use the 8 and 9 bit for the defined construction of the define the name of the RAMs. So, we use the binary values of, that is 0, 0 used for RAM 1, 0, 1 used for RAM 2, 1, 0 used for RAM 3 and 1, 1 used for RAM 4. So, this is the basic address map table that we have to use for construction of the computer system requirement, for fulfillment of the computer system requirement, that is the RAM and the ROM designing. Now, how we have to define these particular addresses? So, this is very important. Let's see. Just take the previous slide and because we need the space. So, we just calculate the first address, that is 00002 007F. So, how we define that particular address? So, we just define 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we start the starting address at this time, all bits are 0. These all bits are 0. Okay. And this basically address with the in the hexadecimal format. So, basically it is belong with the 11, 12, 13, 14, 15, 16 because we start with 1, right. So, there are basically all are zeros in the initial case, in the first address case, and the last address of that particular ROM is all address bits are high. So, it is all ones. So, it is basically all ones. Okay. So how we have to recognize these addresses with the hexadecimal format? So we take the four bits in a one form. So take 4, this is 4, okay, this is 4. So it is basically 0, it recognizes as 0, it also recognizes 0 and is also 0. And we have to group that one, so this is basically 15, 15, 15, 15. So it is basically represented as F, F, F. So the initial address in this case, this is all 0, means 0, 0, 0, 0, 2, 0 to F, 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 F. Basically, how we have to define these bits are F, because the initial case we used only the 10 bits. Okay, so this particular construction, the address bits are 0. So this is not F basically. So it is basically 0, 0. So you don't write these bits at 1 because you used only the 10 bits in this case. Okay, when the size of the RAM and the ROM are increased, so you have to use these 11, 12 or the 16 bits. But in this case, we used only the 10 bits. So we just take these 10 bits. This is 0 in this case and this is also 0. Because we used for the RAM 1, so it is also 0, 0, 0, 0. So how we have to recognize that? So this is basically 15 because all 4 bits are 1, and in this case it is basically 0, 1, 1, 1, 1. So it is basically what? It is 7. It is 0 and it is 0. So the address bits, initial address bits are 0, 0, 0, 0, 2, 0, 0, 7, F. So this is very important thing that you have to define the bit mapping. If you write all ones are there, so the configuration of the RAM size in the hexadecimal form is completely wrong. So you have to just initialize that which RAM address you have to define. So if you used 8 and 9 bits are for the RAM selections, so this is because this address is defined for the RAM 1 and it is initially 0, 0. So we put 0 and 0 are there. If it is for the RAM 2, so it is basically what? It is 0, 1, right? So it is 0, 1. So it is basically 0, 0, F, F. So let's check with the previous slide. So kindly see that initial address is 0, 0, 0, 0, 2, 0, 0, 7, F, due to because we used only these 10 bits in this particular question, right? So it is basically 0, 0, 0, 0, 2, 0, 0, 7, F. And the next address is what? Why it is 8? Basically because we use this 8 is high in this case, and these are 0. This is basically 0 because we find out the initial address. So it is 0, 0, 0, 0, 0, 0, 0, but it is 1. And these all are also 0. So this is the combination of the 4 bits. This is 0. This is basically 1,000,000. So it is 8 in this case, right? And because the end address, these all bits are high, so it is basically 1, 1, 1, 1, 1, 1, 1, 1. So it is basically F in this case because this 8 bit is high, right? So you have to just define, or you have to just alert at the time of the hexadecimal address defining table. So this is very important thing. And let's check with the third addresses. This is 1 in this case, so it is basically 0, 0, 0, 0, 0, 0, 0. This is 0, 0, 0, 0. It is basically 0, 0. But in this case, it is 1, 0, 0, 0. It is 1. So it is basically 1 in this case, and the rest 4 bits are 0. So it is 0. So it start with 0, 1, 0, 0, and the end with 0, 1, 7, F. Because in this case, it is these all are high, but this is 0. And these all are 0. So it is basically 0, 1, 7, F. So this is very important thing, that how many RAMs are there, how we have to select the RAM. If the RAMs are basically 8, so we use a 3:8 decoder, and the bit size address bit lines are we use 8, 9, 10. So it is basically 0, 0, 0 to 1, 1, 1. So this is the basic reference that we have to define the hexadecimal address for each RAM and the ROM. So this is very important. Now, how we have to construct? Just we have to remove that. Okay, this is the connections that how we have to construct the RAM and ROM designing. How the system required the RAM and ROM chips, and how we have to connect each RAM and ROM chip with the defined connections. So this is the basic. These are the data bits for used for the transferring the data from the memory. Now this is the read and write signals. These signals are used from the RAM and the ROM. In ROM only the read signal is used. In RAM both signals are used. These are the address bits. How we have to define these address bits is 1 to 7, because these address bits are common with RAM and ROM, because the ROM required the 9 address lines and the RAM requires the 7 address lines. So these 1 to 7 bits are common. So it is directly common bits we have to transfer from each RAM and ROM. And 8, 9, 10, because the 9 bits are required for the RAM address bits, but 8 and 9 bit are used for the RAM selection. So basically, let's show the result with one by one. We start with write. So we give this write signal to each RAM, not ROM, each RAM, right? In ROM, we don't use that particular signal. In read, we use read signal, read signal, read signal, read signal, and also we use the read signal with this ROM also. This is directly connected with the CS1. Now, these 7 address lines we use for RAM and ROM both. So these 7 bits we use RAM and ROM both. And these 8 and 9 bits are used as a selector for RAM and as a address bits for ROM, address line for ROM. So these 8 and 9 are used as an address line for ROM and used as a selector by using decoder, because we use the 2:4 size decoder. This is 0, 1, 2, 3. When the bits, input bits are 0, 0, so this 0 is selected when it is 0, 1. So this 1 is selected when it is 1, 0, so this 2 is selected when it is 1, 1, so it is this 3 is selected. So correspondingly, these RAM chips are selected. So we have to just select chip select 1 we use for selecting the RAM chips. So it is assigned as high, it is high, it is high, and this is high. So these are used for the chip selectors as a RAM chip selector. Now, for the ROM selector, how we have to define that, how we have to differentiate with the RAM and the ROM. So we use this 10th bit as a RAM and ROM chip selector. So when it is 0, so it is the RAM selection. When it is high, so it is the ROM selection. So we have to transfer that ROM 10th bit with CS2, that is chip select 2, with each RAM. With each RAM. This is the 10 bit, this is chip select 2, this is chip select 2, this is chip select 2. So this is the basic configuration or basic memory address map table with respect to the connections. So this is the basic diagram that how we have to define the 8th, 9th, 10th bit in this particular chip designing, memory chip designing connections. So this is basic. So thank you for this particular lecture. I think it is very useful to you guys. Thank you so much.